Going to be 9 o'clock any second now, and I'm impatient. So I'm sure we'll have a couple of people still walking in. Before I get started, I just want to say thank you everyone for being here. It is 9 a.m. on the last day of the show. And so it's great having this many people here. And as I've been saying to people, the great thing about having 9 a.m. on the last day is I know that I only have the people who really care. So this is great. I will say, disclaimer, this is my first time being in this room. I've been in next door. So a fun little fact about the stage lighting when they have it like this, I can't see most of you except if you're using your cell phones. So if you're tweeting or thinking you're getting away with it, understand you're the only people in the room who I can see because of this lovely glow on your face. So hello everyone, I'm Ben Armstrong. I'm a program manager on the core team at Windows working on kernel, hypervisor, virtualization, all the low-level stuff. And I am here today to talk about Nano Server, which is something we've been working on for a long time. I'm really excited to see it finally coming out to market. Before I get started, I do want to give two disclaimers. The first one is, of all the presentations I've done here, this is the only one where I didn't put the deck together. This was actually put together by a colleague. I can guarantee I'm going to trip up on something. There's going to be at least one, if not a couple of moments where I get to a slide and I'm like, oh, I've already talked about all of this, so I apologize. I've spent an hour this morning trying to go over the slide and get the flow right, but when that moment comes, we'll all just nod and move along. The second disclaimer is that, yes, this is 9 a.m. on a Friday. This is my third session, and so I'm a bit less disciplined than usual. I'm probably going to go off in the weeds and tell stories and wander all over the place. But do hang in, please. Hope we have time for questions at the end. This is some really interesting stuff to talk about. So the first sign that this deck was put together by someone else and not by me is that there's an agenda slide. I hate talking about agenda slides, so instead of talking about the agenda slide, I'm going to say, this is actually Nano Man. This is a mascot that the marketing team put together. And if you have a close look, you'll see I have a shirt which has the three mascots of the core technology for Windows Server 2016. The purple guy on the right is Shielded VM. In the middle, we have Nano Man, and on the other side, we have containers. So you're actually going to see these three characters around in a fair amount of our marketing material. Before I get into the details of how you deploy Nano Server, I want to talk a bit about some of the customer and some of the engineering motivation behind why we did Nano Server. So there are a couple of big things that we were looking at. The first one is really important to understand, and this is the conversation about reboots impact my business. This is something, like, not enough people, like, too many people don't give enough credence and credit to this. This has been something that's been becoming a bigger and bigger focus for us. How many people here are used to the phrase, like talking about uptime in the phrase of how many nines, 3 nines, 4 nines, 5 nines. This is kind of some industry jargon that we like to throw around. But the reality for most people is we don't actually know in an operational sense what that actually maps to. So let me give you the shorthand. 4 nines means over the entirety of a year you have an hour and a half downtime. 5 nines means over the entirety of a year, you have 5 minutes downtime. If you are rebooting once a month for patches, you're not in 5 nines. You're lucky if you're in 4 nines. Chances are you're in 3 nines. So rebooting when looking at enterprise-grade, commercial-grade solutions is a big problem. Server images are too big. This was actually a really interesting one, and I'll talk about this in a couple of later slides. This was one that we ignored for a long time, and it was interesting that this started to become a real conversation. And infrastructure requires too much resources. So these were some of the background ones, but none of this compared to the big one, and that is security. And I talked about this earlier this week, but one thing that everyone, and especially everyone in this room, should be very clear about and should feel very confident talking to their customers, to their businesses, to their decision makers is there should be no doubt that the security landscape for IT has got drastically worse over the last decade. The level of attack, the sophistication of attack is unbelievable. And it is just getting worse. And more than ever, we need to be thinking first and foremost, how do we build, deploy, and maintain systems where we have absolute assurance that they are secure, trustworthy, and haven't been compromised. So all of this boils down to, okay, I need a server that is just the bare minimum bits that I need. And this has been something that we've been working on for a while. This has been a long journey for us. One of the first steps, and something that's really served us well, is Windows Server has always been built on the foundation of, we have the server platform and we have an array of roles that you pick and choose, and you only install the roles that you want. In Windows Server 2008, we introduced Windows Server Core. A subtle thing that we did in Windows Server 2012, which we never spent enough time talking about, this was a lot of engineering work, but we actually went through and re-architected so that Windows became a layered system where the different installations of Windows built one on top of the other. So when you were running full Windows Server, you actually had Windows Server Core underneath there, and you had the components layered on top of each other. So we've been working on this. At the same time, we've been gaining experience ourselves in what it means to run cloud and to run cloud at scale, both through our Azure platform and through our cloud platform system. Now, here's where I want to take a moment to talk about the server image size. For a long time, we've had people, come to us and be like, hey, Windows Server uses a lot of space on disk for, if I want to use it for a Hyper-V server, if I want to use it for a file server, if I want to use it for something simple. Most often the conversation that would happen then is someone would come to us and say that, and we'd say like, yeah, we get that, but you're talking about servers where you have like, a 200 gig hard drive in there sitting nothing. And is this really that big of an issue to you? Like, what's the actual impact? And the response from customers would usually be like, it isn't really an issue, it's just annoying. And so we'd always kind of gone like, okay, yeah, we get that the size of the image is annoying, and we have a lot of like policies and processes inside Microsoft to try and stop random engineering teams from arbitrarily making the size of Windows twice as large, which someone always tries to do in every release. It's fantastic. In every release, there's some engineering team that comes up with a great idea for some cool new feature that would have the side effect of doubling the size of Windows. Thankfully, we do have the procedures that catch that. But the most interesting conversation actually happened inside Azure. Because fairly early on in the days of Azure, the guys building and running Azure came to us on the core team and they were like, Windows images are really large. And we're like, yeah, we know, but like, is it like all the Azure machines have local disks and you're booting off them and they have space and like what's the big deal? And the Azure team looked at us and went, no, you don't understand. What the big deal is that we're booting up pods that contain 800 computers, and we're pixie booting them all and streaming the image down. and we don't have enough network bandwidth for this. And I was like, oh, okay. Because Azure does all of its OS deployment to today, and this wasn't the case when we started this conversation, but today to millions of computers over an internal backbone. And yes, the size of the image really matters. And so that was, that was a big motivator, was starting to think about, okay, how do we do our own hyperscale deployments of Windows Server? So, okay, it has to be highly optimized. And this is where we started with the concept of, okay, just enough OS. And the idea here was, really kind of taking a step back. And if you think about the philosophy behind Windows and behind Windows Server prior to Nano, with Windows Server, even with Windows Server Core, what we're doing is we're giving you a blank checkbook. We give you a general purpose operating system, and you deploy it, and after you've deployed it, you can make up your mind and go like, okay, like this one I'm going to make a web server, this one I'm going to do this with. Nano Server is really changing that mental model and changing that paradigm, where now we're saying, okay, before you start deployment, you need to know what your end goal is. And you need to be able to tell us, oh, this is a Hyper-V server, this is a web server, it's going to run in this environment, it's going to run in this configuration. And we will build a highly tailored, optimized OS just for that. And so what this is, you can also tell this is not my slide because I never do builds like this. They always throw me. I always have just all the text come in at once. So what this looks like is there are really two scenarios that we've gone after for this. The first one is, okay, we've identified key roles that we think are interesting in this deployment. Now, I do want to take, we've got a list here. These are the roles that you can currently run on Nano Server: Hyper-V, Scale-Out File Server, Clustering, IIS, DNS, a bunch of infrastructure that supports that, Windows Defender, TPM support, PowerShell, etc. I do want to take a moment to call out, because I know that if I don't talk about this, I'm going to get to the end of the session. One of the first questions is going to be, someone's going to be like, what about this server role? When are we going to have this on Nano Server? So here I'm going to go off script for a bit, because they don't have a slide on this, and this is a lovely technical detail, the sort of thing I like to talk about. So when we were working on trimming down Nano Server, there was a lot of obvious stuff, a lot of low-hanging fruit where we're like, okay, obviously we're going to get rid of, so by default we don't have WoW 64 there, so you can't run 32-bit apps. It's all 64-bit native, Service 64 only. Great, that's an obvious one. A big chunk of stuff gone. And there was a whole process that we went through to just be like, okay, like on a server we don't need this subsystem, we don't need that subsystem, fine. That did not get it down small enough for us. And what we actually spent a lot of time going through is, the core foundational API that is present on all Windows systems is the Win32 API. And Win32 API, in compute terms, is really freaking old. And what happens when you have an API set that is really old and has been maintained is that you get lots of APIs with a high level of redundancy. Where what'll happen will be like, in 1998, we implemented an API that allowed you to access a file in a certain way. 2 years later, we realized, oh, there's a scenario where we need to support a different type of access, but we now have a bunch of apps that use that API, so we'll create a new API that does kind of the same thing, but with a bunch of different parameters. And the net result is, and I know because we actually went through and did this activity, is that if you go through the complete set of Win32 APIs and look at, okay, conceptually, what do these APIs do? Like conceptually, what do they do? About 80% of Win32 is redundant. About 80% of Win32 is doing something that another API does, but is there for compatibility reasons. And so in Nano Server, we cut all of that. So a really important detail to understand here is, and I'm going to be talking about key roles, and I'm going to be talking about new applications. And the reason why I talk about those two is because there's a bunch of Win32 missing. And getting roles and features and applications up and running on Nano Server is not free from a development point of view. We think it's a worthwhile investment. So in the case of Hyper-V, which is the one that I was most deeply involved in, and actually two great examples to compare and contrast. Hyper-V and Windows containers. Hyper-V was a product that was built before we started working on Nano Server. We had to go through and do the work to refactor Hyper-V to run on top of Nano Server. It took my engineering team about 9 months. About 9 months of just going through the code, analyzing all the APIs we use, and getting them up and running. Now, in comparison, Windows Server containers took 0 days because from day one, we built it on Nano Server. So from day one, when we started working on the Windows Container project, we were already working on Nano Server. We knew that this was an effort that was ongoing. So why do I say all of this? The reason why I say all of this is I want all of you to be aware that when we look at our existing stock of Windows Server roles and features, we are not in the mindset of, oh yeah, we're just going to bring all of those across to Nano Server, because there's a chunk of engineering work. We are in the mindset where we're like, we're going to bring some of those roles across to Nano Server. Some of those roles we're going to say, no, that's going to be a server core role. What I would encourage you is, as you start using Nano Server and think about roles where it's like, man, I'd really like to have this in Nano Server, be giving us that feedback. I really encourage, we have the Windows Server user voice. And the engineering team pays a lot of attention to that. So I would encourage people to go to the Windows Server user voice site and putting votes, comments down on like, hey, we want to see this role on Nano Server, so on. For instance, one of the ones, just to head off this question, because this is very high on our user feedback list. Note that I'm not committing to doing it. I'm just saying that we know that it is high demand, is Active Directory. That's one of the first ones that everyone asks for. But right now, it is this key set of features and roles. It also has management agents, and I'll talk about that in a little bit. So that's the roles. The other use is for new applications. And this is something that we're trying to be very crisp about. How many people here have development teams in their organization? Fantastic. You should absolutely be talking to them about looking at Nano Server, looking at Windows containers, looking at Nano and containers, and using it to speed up their development process, speed up their deployment cycle, so on. So a couple of things to call out. The first thing is, most development teams these days don't actually develop on Win32. They develop on frameworks that run on top of Win32. We've done a bunch of work so that the .NET Core 5 and the ASP.NET Core 5 work all just runs on top of Nano. So if you have people who are doing ASP development, getting their code over and running on Nano is fairly straightforward. At the same time, we've looked at a number of the open source frameworks, Node.js, Python, Ruby, so on, and we've made sure that they all work as well, so that whatever frameworks people are using, chances are they work well on Nano. The two things that I do want to be really crisp about, and this is why we talk about developing new applications, is, let me tell you, most of your ASP.NET applications that you guys have in your enterprises are running on .NET 3.5.1. We know this. we've talked to a lot of people, and .NET 3.5.1 does not run on Nano Server. So if you are thinking you can take that 4-year-old internal web application and move it over to Nano Server without engaging your development team, wrong. Like that is not the model. That is a great application to continue running in Windows Server Core. However, as you're developing new applications, be looking at Nano. Similarly on the Win32, if you do have Win32 apps, you need to make sure that the developers are involved in that. Now, I expect that not many of you have developers who are going directly against Win32. If you do, the key thing to know is we've worked very closely with the Visual Studio team, and we actually have a development profile specifically for Nano Server, which is absolutely fantastic because you can have Visual Studio on your Windows 10 desktop, and you can say, oh, my target is Nano Server, and then it will come and put red squiggles all over your code. It will go through every API that you're calling in Win32 that isn't on Nano Server and be like, nope, like this one isn't here, consider this alternate. So it's a very handy tool for developers to get it up and running. But really, the mental model that you should have here is, for your in-house applications, this is a great development platform moving forward. For your older applications, Server Core, Windows Server Full continues to be the great option it always has been for those. So with kind of all that landscape, let's talk now about the deploying and configuring Nano Server. Once again, build options. I hate these slides. There we go. So this is really one of the big mental shifts for the server admins, for the ops people, is, I talked about with Windows Server, we have this model where we give you this blank slate. With Nano Server, you build the image customized. And a couple of key details to call out here, and two of the biggest differences here. The first big difference comes around drivers. Now, if you look at Windows in general and you understand the philosophy of the Windows driver model, Windows has always been designed with the idea that, like, you're going to take Windows, you're going to install it on any arbitrary piece of hardware, we're going to madly scramble and figure out what drivers you need to get running. And as you're using Windows, you're going to randomly remove and plug in different devices, and we're going to somehow magically make it work. Now, the details for somehow magically make it work is we have a huge chunk of code called the plug-and-play engine that has huge amounts of code in it, huge amounts of dependency, and we're constantly maintaining a huge cache of drivers just on the off chance that maybe you plug in something like that. And that is actually a large chunk of Windows. And none of that is in Nano Server. And the reason why none of that is in Nano Server, 3 reasons. The first one is, in case you didn't get the hint, that takes up a lot of space. And that's a lot of our patch burden, which if you go back to why did we do Nano Server, we wanted to reduce our footprint and reduce our patch burden. So that's the first reason. The second reason is, you want to know what people do not tend to do with servers? They do not tend to plug in random pieces of hardware at random times. Like, very much a pattern we have to care about on desktop, but for most people, you buy a server, you configure it, and you never touch it again. So having all this code there and having all the infrastructure there so you can randomly plug stuff in doesn't make sense. The third thing, which is just an observation about servers, is when we go and we talk to data centers and we talk to people running server infrastructures, the other thing that people tend to do is you standardize your hardware. So yes, occasionally we come across customers where their data center is a mosaic of hardware variety. But the most common pattern is that people have trusted vendors, they have trusted models, they deploy servers in waves, and for most people, there is a small handful of, okay, we have about like 5 or 6 hardware profiles in our data center. So I know one of the things that I think is amazing and wonderful is just how disciplined the guys who run Azure have been. So we run, I've lost track of how many global data centers we have on Azure. We have many global data centers. We have over 1 million servers, but we actually, and this is as someone who works on the team that has to build the stuff that runs in Azure, this makes my life really easy. We have 4 servers. There are 4 hardware profiles that run in Azure. And they've been really disciplined. Every 2 years we do a hardware refresh. And it's great. But that's the way people like to run their server infrastructure. So in that world, rather than having all this infrastructure where we can dynamically detect this, with Nano Server we instead say, okay, tell us the drivers. Now the nice thing, and this was a big requirement for us, is Nano Server does not require customized drivers. You use the same drivers on Nano Server that you do on Server Core, that you do on Server Full. Same drivers, but you do have to load them ahead of time. Similarly, we allow you to load the roles and features ahead of time. Now, this is something that's changed over the release. Actually, a quick, I'd like to, so how many people have tried installing Nano Server? So how many people tried on GA, on the release? Okay, TP5, TP4, TP3, TP2. Wow. TP2 was terrible. It's awful. No, I was just curious because this is something that one of the things we built Nano Server first and foremost for Azure, and then we've brought it out to customers. And part of that learning has been that our customers have different requirements to Azure. My favorite one with TP2 was the first build of Nano Server we put out there would draw nothing to the screen, which the Azure team didn't care about because they never attached monitors to their computers. But a bunch of our customers were somewhat disturbed by the fact that you would boot Nano Server and it never looked like it exited BIOS because it never drew anything to the screen. So we allow you to go through and configure these packages offline. So we have a bunch of tooling that allows you to configure this. And I have 3 slides. Rather than talking through all of this, I'm going to jump straight through to the demo, because demos are more fun. So let's go across and I'll show you what this actually looks like. So the key thing to understand, for most of the technical previews, the way that you've installed Nano Server has been to use a PowerShell script. And this was on one of the slides, I'll take a moment to step through. We've had a lot of people say like, hey, we hear about Nano Server, but when I go to boot off the DVD, the installation media, it just offers Server Core or Full Server. And we don't have Nano Server there, and the reason why is because different deployment model. You can't do a general install of Nano Server. You have to do a specialized install of Nano Server. And the deployment model is you're going to build your Nano Server image and deploy it. And so if you actually go and have a look, anytime you get Windows Server, just like you buy Server, you're licensed for Core or Full, that's just a deployment option. Nano is also a deployment option. However, it doesn't appear if you boot off it, but it is here on the CD. So if I go on the CD, here's Nano Server. And what we actually have is, if I go into Nano Server Image Generator, we have a PowerShell module that allows you to generate your Nano Server image. And for all of the technical previews, that has been our recommended way of doing this. And as the technical previews have been going on, we've been growing that. Now, with the GA release of Windows Server, we now have the Nano Server Image Builder tool. And this is a graphical tool that we've released that allows you to, you can download this, set this up on Windows 10, And it allows you to very quickly build your Nano Server. Let me zoom in a little so that people can see this a bit better. So I've launched this. Now, when we talk about building a Nano Server image, there are two ways that you can build and deploy a Nano Server image. You can build a virtual hard drive, or you can build a WIM file. Now, there's pros and cons to both options. Virtual hard drives and booting off of virtual hard drives actually tend to give you a bit more flexibility, and they enable some more advanced deployment and patching scenarios. Virtual hard drive is actually the model that we use inside Azure. So inside Azure, we build our images for our servers, for the physical servers, as virtual hard drives. We push the virtual hard drives down and we boot off of them. And as I said, it gives us some interesting flexibility. The other option is to create a WIM file. And this tool supports both. Now, the advantage of a WIM file is that when you use a WIM file, we already have a bunch of infrastructure and deployment around WIM files. So you can build a WIM file if you're using WDS deployment, doing network deployment. Having a WIM file that's your Nano Server image makes that very easy. In this wizard, we give you two options. The first option, which is the one that I'm going to do, is to say, let's create an image, and you're going to deploy that image to your server through some means that we don't know. Whether it is using a WDS server, whether it's some other form of distribution. The other option that we provide here, which is really nice, is creating the bootable USB media. Now, I do want to be really clear, this is not creating a USB stick that you boot Nano Server off of and run it. Rather, this is creating a USB stick that you're going to take over to your server and install Nano Server from. So that's what, if I select that option, that's what's going to happen. But I'm going to say, let's do the image. So it's going to come up, and it tells me things I should know. I should know my network configuration. I should know where my install media is. And also, if I need drivers, I should have that accessible. So I'm going to browse. I have my install media is just here, my H drive. It's going to give me a nice little EULA. Okay, and now it's going to ask me a couple of questions. So the first question it's going to ask me is this a virtual machine or a physical machine? Here's where the first bit of the philosophy of Nano Server starts to come through. So here's an interesting little detail about Windows Server Core and Windows Server Full. If you go to your Windows Server Core or Full that's installed on your physical box right now, not your virtual machine, your physical box, it has all the drivers and all the services that are only needed if it's running inside a virtual machine. You can actually go and see that. If you go to your physical box and you look through the service list, you'll see a bunch of services. Now they're off because we've detected we're on a physical machine. So why are those there? Those are there for two reasons. The first reason why they're there is because that's the way we do Windows. We put everything in that you might need. The second reason is they're there so that, like, yeah, we know you deployed that on a physical box today, but maybe you're going to P2V that at some time in the future. And on the off chance that you will one day P2V that, we have all the stuff there. And that's the philosophy of Windows Server Full. Nano Server does not do that. So I'm going to create a VHD. If I select physical machine image, this will not boot in a virtual machine because it will not have the drivers, the services, and the infrastructure necessary to boot in a virtual machine. If I select virtual machine, which is what I'm going to do, it will not boot on a physical computer because it does not have the drivers and infrastructure needed for that. So I'm going to stick with virtual machine, give a highly creative virtual hard drive name, and actually I'm going to let's do physical machine because I want to show you some of the options. So if I go physical machine, Here it's going to say, hey, like, where do we want to stick this when we're done? So I'll go ahead with that. Actually, no, we'll go back. That's not going to work. That was going to put it on my SD card. So now I've said, okay, we're creating a VHD. The next question is, what are the packages? Now, an important thing to call out, from most of the technical previews, the experience has been that when you create your Nano image, you have to define the packages that run in the Nano image, and if you don't have them. Once again, tailor-built images. When you look at Windows Server Core, Windows Server Full, normally, we have this experience where you say, oh, like, there are no roles enabled, oh, I'm going to go and enable this role, and it all just magically works. Well, how does that all just magically work? It all magically works because when you installed Windows, we put down all binaries for every possible role on the disk. They're just not turned on. And, side note, because they're all there on the disk, whenever Patch Tuesday comes around, we're pulling down any patches that apply to those so that if one day you decide to turn them on, you get the patched up-to-date version. Now, we do not do that with Nano Server. We do not put anything on the disk that is not there when you specify installation. Now, an important thing that, and this is very recent, it wasn't in most of the technical previews, I'll talk about it a little bit in the slides. This is something that we've been working on for a bit now, is with the GA release, we do now have the ability to, after you've deployed Nano Server, go and get roles from Windows Update and pull them down and deploy them post-build. I would not recommend that approach. It is there, it is possible, but really the best way, and I'll talk about why this is, the best way to do this is to define your roles as part of your image build. So I'm building a virtual machine. I'm going to go ahead, I'm going to say I want failover clustering, and I want file server, because I'm going to use this as a file server virtual machine. I can choose data center or standard. Let's go next. Here's where I can select drivers. Obviously, because I'm doing a virtual machine, I'm not going to add any drivers. But if I was doing a physical computer, here's where if I have my drivers package for my vendor, I can go in and I can say, oh, I need this fiber channel driver, I need this driver, that driver, so on. Now, here's where we get a couple of things. So I can specify the computer name. And now, there's going to be a bunch of options in this wizard where you can set them through the wizard, you can set them through PowerShell, or you can do them manually through other ways. We decided to make this as easy and streamlined as possible and allow you to do as much offline as possible. So I can say, okay, this is going to be test 7. It's going to have the highly secure password of password and time zone. Similarly, once again, in the spirit of everything offline, we allow you to do domain join as part of the offline image creation. I'm going to skip over this, but actually in a lot of my demo builds, I always use this. And there are two options that we have here. The first one is, you can see, use an existing domain name, and this is if you've gone ahead and pre-provisioned a computer account for it. The second one is using a domain blob file. And this is what I use in most of my deployments. And it's a little bit complicated, but it's a process that we have well documented. We have a command line tool where ahead of time you can go and say, okay, I want to generate a blob that is the credential and authentication to join this image to the domain. And it will get Active Directory, it will set up. It's a command line tool that you run from a domain join system. And then it gives you a blob that you provide here. And then when this system boots, it's able to join the domain. Now, networking. This is really important. Because as I will show later on, one of the trimmed down aspects of Nano is there is almost nothing you can do from the Nano console. And so what is most vital about Nano Server is that you are able to connect remotely over PowerShell or whatever remote management tools that you need. So first thing I would highly recommend in most situations, you're going to want to enable WinRM so that you can do PowerShell remoting. And you're going to want to configure your networking, either using DHCP or a manual IP address. So I'm just going to go with DHCP in this case. We also have a bunch of advanced configuration options. I'm going to skip over these, but you can specify startup scripts. You can apply servicing packages. That's a really great option. I use it myself in my build scripts so that when you deploy, you don't have to check Windows Update. You can know that, hey, this image is being built with the latest bits. And you can set a bunch of other options. So I'm going to go with basic. Here we have a nice little confirmation that says this is what we're doing. And I'm actually going to go ahead and create this. And I'm going to create it for two reasons. The first one is to show you that this actually doesn't take a long time. It's a really fast process. So I tested this morning, and it took about 2.5 minutes. The second thing is I mentioned that we have the PowerShell module that goes through and does this all for you. And this wizard that I've just run is actually, for the most part, just a front end on top of this PowerShell module. And you can actually see that down the bottom here, we have the PowerShell command that was used to create this. And you can just copy and paste that. And if I want to recreate this image in the future, I don't have to go through the wizard. I can just run the PowerShell command. Now, the one thing to be aware, I did say for the most part, this is just a wrapper on the PowerShell module. It also does have a dependency on the Windows ADK. And that is there so that if you choose to create the bootable USB disk, we will actually roll a Windows PE image for you automatically and deploy it to that USB key. So what's going on, by the way, while this is happening is, and you can see a bunch of text flicking by, we're going through and we're doing all the work that normally you would do by hand and it would be a real pain. So we're creating a virtual hard drive, we're mounting it, we're applying the Vim offline, we're doing role configuration offline. The thing that I really like about this, because as a side note, how many people here have ever got an unattended file right the first time? I don't have any liars. That's fantastic. No, I've asked that question so many times, and usually there's someone who's like, me. And I'm like, liar. So, as I was going through this wizard, you saw there were a bunch of options for admin password and IP address and so on. And I got to tell you, side note, I've spent so much time rolling unattended files. I have never been able to get IP address configuration to work. I have tried to do it so many times. But this script, actually, all of those things, we auto-generate an unattended file for you, and we stick it in the image. And I actually love having it there because I've run this script a couple of times just so I can go and crack the virtual hard drive and fish out the unattended file and be like, yes, I have one that works that sets the IP address. So there we are, 2 minutes 30, and it's gone ahead and it's created that for us. If I jump over to my D drive, I should have my nice foo.vhd, and it's 590 meg. It's a file server, it's got clustering, it's ready to run in a virtual machine, it's got the computer name I specified. So nice and simple and fast. So with that, let's jump back to my slides. So I mentioned we can do online, and this is how you do online role installation using install package provider and then using find Nano Server package, install Nano Server package. But as I said, I would recommend that you don't do it this way, that you do it as part of the build. For an important thing to understand for agents, and I talked about building new applications, not using old ones. One of the big things that does not exist on Nano is MSI. MSI is the standard Windows installer. It is a huge chunk of code. We don't support MSI. And this comes back to, don't be looking at just bringing across existing apps. You want to bring new ones across. We do provide updated agents for System Center. If you're using third-party management tools, you're going to have to reach out to them and say, hey, do you have updated versions for Nano? So now let's talk about managing Nano Server. So there are a couple of options here. One that I'm going to hammer over and over again because people keep on missing this, and this is pretty much any tool that you use to remotely manage Windows Server Core or Windows Server Full works to remotely manage Nano Server. I had a customer meeting the other day where the customer was surprised to be like, oh, you can use Operations Manager to manage Nano Server? Yes, you can. Like anything that you use to remotely manage Windows, you can use to remotely manage Nano Server. So, for example, the Hyper-V management tools work great against Nano Server remotely. One of our staples that we point everyone to, of course, is PowerShell remoting. And that is kind of our fallback position is PowerShell remoting, hugely powerful, but all the remote management tools work. Now, on top of those remote management tools, we have a new offering that we've brought out. This is an Azure hosted service called the Remote Management Server Toolkit that provides this nice graphical interface for managing your Nano Server images. It's really cool. It's currently in public preview. But I do want to highlight that all your existing tools, Server Manager, Failover Manager, Hyper-V Manager, Perfmon, PowerShell, anything that you can run remotely against Windows Server works on Nano Server 2. On top of this, we've actually done a whole bunch of work to get as much PowerShell running directly on Nano Server as possible. So there are two ways that you can interact with Nano Server through PowerShell. One way is you can use commandlets that support the -computer name parameter or -sim session and allow you to target remote boxes. The other way is you can log into a PowerShell session on your Nano Server and run commandlets there. So let me quickly show you what that looks like. So I actually have a Nano Server virtual machine running here, and I'm going to jump into a PowerShell console. Now, if this was over the network, I would do enter PS session, and I would do -computer name. I would specify the network name of my computer. Since I'm doing a demo, actually let me remember to zoom in so that people can read my text. Instead of doing computer name, I'm going to do VM name. Let's see if I have this in my clipboard. Yes. First, when I was practicing this demo this morning, I mistyped the VM name like 3 times. So I'm going to say that. It's going to ask me, what are the credentials? I'm going to be quiet, otherwise I'm just going to say my password while I'm typing. And there, I have a PowerShell session inside this Nano image. If you have a look, there's very little there. I can do get process, and there's a much smaller set of processes than you're used to seeing inside Windows. But a key thing to understand is we actually, even though this is Nano Server and it's a reduced footprint, we actually have a huge amount of the PowerShell commands available and ready to use here. So as you can see, these are all the ones. I actually have this set up. This is a nested Hyper-V server. And all the Hyper-V commands are here. So I can do anything with PowerShell that I would expect to do with a server core box. So that's just a quick demonstration of what that looks like. One interesting detail just with remote management that we did, not everyone uses this. This is something that I've only seen customers use at large scale. For people who are doing like a 4-node or an 8-node cluster on Nano Server, most people are happy to just iterate and repeat and get their image working, and once it's up and working, great. But we have a number of customers, i.e. Azure, but also hosters and so on, who are running Nano Server on hundreds or thousands of boxes. And one of the problems that we found was that it was actually really hard to diagnose boot failure. So if something caused Nano Server to fail to boot before it got up to remote management. To address that, we have some functionality which is set up and boot event collection. There's a white paper on how to set this up. The long and the short of it is we allow you to set up a special role on a centralized Windows server that is a collection point for boot event logs and information. You then set up your Nano Server deployment so that as they boot, they actually stream out their event log and their information to that central point, so that if you have a early boot failure on a Nano Server, it's very easy to understand and diagnose what's happening. Another thing for remote management is what we call the recovery console. And I'm going to switch across to demo that as well. And this is going to be my last demo. I have really exciting demos in this. They're all text. So this is my Nano Server VM. And as I mentioned, when we did the first technical preview of Nano Server, this would have actually just been a blank screen because we had nothing there. And it's always been our goal to be like, okay, this should be as minimal as possible, and we really want people doing remote management. But we had a lot of customer feedback going like, okay, we do need a console for a couple of things. So we've built this console to address just those concerns. So I'm going to log in here and show you what you can do with this console and why it's here. So the first reason why this console is here is for this lovely page. And this lovely descriptive page tells you one thing, and that is, yes, the server is running. Genuinely, we had a lot of people who were like, yeah, I get all of this, but when I'm in the data center, I want to be able to just flick over and confirm that, yeah, that server is running. So, okay, fine. Yes, the server is running. We'll tell you the name, we'll tell you how long it's been up, we'll tell you basic information. The next thing that people really asked for is, as I've mentioned, we want to see these remotely managed, and we want to, I've showed you the PowerShell management experience. People were really worried that, like, what if I break networking? What if I break remote management? And so we've given you some really basic, like, get remote management back up and running tools. So if I come here to WinRM, this is literally just an option to turn WinRM back on. So if someone connected to your box and killed the WinRM service or did something crazy like this, you can come here, hit enter, we will turn WinRM back on. Similar deal with the firewall. We don't allow you to create firewall rules or do complicated things, but you can come here and just enable or disable rules. So you can see here I've selected a rule. I can hit F4 to enable or disable that rule, so that if someone's blocked a firewall or allowed a firewall that they shouldn't, you can come in and do that. On the networking, we have a couple of more options here. The first one is we do allow you to go through and configure IP addresses and routing table details so that if something gets messed up and you need to get it back on, you can. So if you see here, I've got this one, I can come in and I can go, okay, like here are my IPv4 details and so on, just to get the box up and running. This is a virtual machine, and I have a virtual network switch. And we actually had a lot of discussion about what we should provide around virtual networking. And the conclusion that we came to was, actually, for virtual networking, it can be really complicated. The purpose of this console is just to let you get things back up and running. So the only option we provide here is you can see the switch, and if you've done something stupid, you can remove it. So the idea being that, like, if you've messed up your virtual switch, you can come in here and tell Nano Server, delete the virtual switch, get me back to blank, I'll go and connect remotely and create a new virtual switch. The final thing that we have through the recovery console, now this VM host option only shows up if you're running Hyper-V. We did have, actually, not the second final thing, we did have a lot of people say, if it's a Hyper-V server, just let me know that my VMs are running. So we have this guest status so that you can come in, and if you're in the data center and you're troubleshooting an issue and you want to know, like, wait a second, are all the VMs still running on this server? You can go and check that. And the final thing is, we did have people say, hey, if I went too far. I have to log back in. Also have to type administrator correctly. We had people say like, hey, if I'm actually in the data center and I'm troubleshooting, I want to have a way to be able to cleanly shut down a system. And so that's what we have here down the bottom. You can see Control F6 for restart, Control F12 for shutdown. But that is it. This is not a general configuration thing. This is very much a recovery experience. So, with all that said and done, what has been the end results of this? And this is the really interesting thing to me. So let's talk about security. Here we have a bunch of stats: drivers loaded, services running, ports open, on default Windows configurations. And this is pre-tuned. I've helped a number of customers standing up Hyper-V servers on Nano Server. We usually get it down to 2 or 3 ports open, but this is just out-of-the-box configuration. Resource utilization. Fewer processes running by default, a lot less I/O and boot, and a lot less memory usage. Most of the time when I'm on stage doing demos with Nano Server in a VM, I've only configured that VM with 256 meg of memory. Runs great. You know, and you can run web servers and run all sorts of things. Deployment improvements. This one is massive. You know, so you saw significant reduction in disk size. So usually around 500 meg, and that results in a reduction in setup time. You know, and one of the really interesting things to talk about is, you know, what we're seeing is for the average customer, building a new image and getting it deployed on a piece of hardware and booted is usually under 5 minutes. And so we actually have a lot of customers, and this is where I've been saying we really recommend that rather than installing things online, you should do it in the build process. We have a lot of customers who are actually going, you know what? Like, I'm just going to make build part of my deployment process. Whenever I have to deploy, I'm going to build. So nice customer quote. I'm skipping over this because we're starting to run short on time. The final thing I do want to talk about is the servicing model. This is something that we announced fairly recently, and I do want to step through it. With Windows as a whole moving to Windows as a service, one of the things that we've announced for Windows Server is we've said we're going to have a long-term servicing branch, which is our typical 5 plus 5 years, and we're going to have a current branch for business, which is not 5 plus 5 years. And right now, Nano Server is on the current branch for business. So what does this mean? What this means from a servicing and release point of view is, while with Windows Server Core and Windows Server 2012, we have the 5 plus 5 support, with Nano Server, we are going to be releasing a new version of Nano Server about every year, and we will support, sorry, let me go back, we will support N-2. So there is an expectation that if you're on Nano Server, you're going to be upgrading. Now, most people I talk about to this are like, ooh, I'm not sure about that. Well, let me give you a little inside detail. I just talked about, you know, build, deploy Nano Server taking about 5 minutes. I've been talking about the security improvements of Nano Server. We've done a bunch of number crunching where we've shown that if you're running full Windows Server, you are, over the last couple of years, you have rebooted that server 11 out of 12 months for a security patch. If you're running Server Core, you've rebooted that server 6 out of 12 months for a security patch. If we'd had Nano Server out, because we've had it internally while we've been working on it, you would have rebooted that once every 9 months. And so what we're actually talking to a lot of customers about is we're saying, look, here's our recommendation. Our recommendation is that you're going to deploy Nano Server, and when we come out with the next version of Nano Server, then you're just going to use that as the way you patch it. In that rather than having, deploying a patch and taking the reboot then, like, okay, we got a security up. That's my thing saying I'm out of time. So, okay, we've got a security update. Go through the pain of a 2.5-minute build, 1-minute deploy to go to the new version of Nano Server. So this is my wrap-up slide, and my last slide, and I'm a couple of seconds over time. So this is kind of the wrap-up. Our big ask, there are two big asks we have here. The first one is, please be trying this out, figuring it out. The second one is, speaking as the Hyper-V person, I want there to be no doubt, we strongly recommend Nano Server as the Hyper-V host of choice. So with all that, I'd like to thank you for your time. And I'll be hanging around and happy to answer questions. We do have another session coming in here, so I'll have to get off stage fairly soon.